For your finding average atomic mass problems, you need to know a few different things. First is a little bit about isotopes. For your isotopes, you have a mass number that's given. So this 85 is the mass number for this particular atom of rubidium. That just means that we know how many protons and how many neutrons are inside of that atom. This one has a mass of 87. So the difference between this one and this one with the mass of 85 versus 87 is the rubidium 87 just has 2 extra neutrons inside of the nucleus of the atom to hold together the protons. The second thing that you need to know is you have different numbers or amounts of the different isotopes that naturally occur. So 72.2% of the time you have rubidium 85. Or 27.8% of the time you have rubidium with a mass of 87. With those two different masses, the percentages should equal 100% because overall that's how many you have that naturally occur. So what we actually do with these different percentages is we're going to be able to calculate the mass that's on the periodic table. So if we look at rubidium on the periodic table, it says that it has an average atomic mass of 85.47. Now that average is actually something called a weighted average, where it takes into consideration that 72% of the time you have a mass of 85, and only 28% of the time roughly you have a mass of 87. So to get your equation, you're going to have something called the relative abundance, RA. Relative abundance is just taking your percentage and turning it into a decimal. So if you wanted to take your percentage and turn it into a decimal, you can do a couple different things. This 72.2%, you can divide by 100, or you can just move your decimal place 2 times, 1, 2, and that'll give you 0.722. Either way, it's the same thing. So again, you can take your calculator, and if you take your calculator 72.2 divided by 100, that'll give it back into that relative abundance, turning it into a decimal, or just moving your decimal place 2 times. Either way, it's totally up to you what makes sense to you. So we're going to take our relative abundance, and we're going to multiply it by the mass that's given for that particular isotope. So we would take 0.722 times 85, and we would get an answer. We would do the same thing here, move our decimal place twice, or divide by 100. So 0.278 times 87. And then we're going to add our answers together. What that does, like I said, is it just takes into consideration that 72% of the time we have a mass of 85. So if we wanted to find the answer for the average atomic mass of rubidium, we would take your 0.722 times 85. That's 61.37. Same thing down here, 0.278 times 87, which is the mass that was given in the problem. 24.816, and I would add those two together. When I add these two together, I get 85.556. For right now, we're just rounding to 2 decimal places because we haven't learned about significant figures yet. So we would just have 85.56. The unit that's actually used for these is AMU, atomic mass unit. If you wanted to check your answer pretty quickly, you can look at the periodic table. Now each periodic table is just a little bit different, and of course I'm not going to give you the same answer that's identical on the periodic table just to make you do some calculations. But here it says that it's 85.47. We got 85 point, oops, I don't know where I got that number from. How about 0.56 when we round it? So 85.56 is very, very, very close. So with your average atomic mass, what you're going to do is for that percentage, turn it into a decimal, multiply it by your mass. If we do another example, we'll just do the second problem here for uranium. It says that we have 3 common isotopes of uranium. We have uranium-234, uranium-235, and we have uranium-238. If we want to set it up a little differently than what I have here, more like the equation, which this is the equation that will be given to you on the test. It'll be written just like that. What we're going to do is we're going to take our parentheses. We have a mass of 234 and the percentage here. Move your decimal place 2 times, 1, 2. So we have 0.0001 times 234. Close your parentheses. Add that to 0.12, so 0.0071 times 235 plus 0.9928 times 238. We're going to hit equals. To plug this into your calculator, instead of doing each individual step like I have up here, if you plug it in identical to this in your calculator using the parentheses, you don't actually have to write down your answers as you go. So we're going to take how about open parentheses, 0.0001 times 234, close parentheses, plus open parentheses, 0.0071 times 235, close parentheses, plus 0.9928 times 238, close up your parentheses and hit equals. 237.98 when I round it to 2 decimal places, AMU. We want to check our answer just to see if we're close. Uranium is down here on the periodic table, 238.03. That's very close to that answer, so that's a very plausible answer. So when you're doing these problems, you just have to take your percentage, turn it into a decimal, multiply it by the mass, and do that as many times as you need to for that problem. So in this one I had 2 isotopes, so I did that twice. If we look at this next problem here that we're not going to do together, we have 5 common isotopes, so we would do that process 5 times. If we have 13 isotopes, we would do it 13 times.